right? So you have to understand that writing paper is very, very important for your examination, right? So I will tell you some tricks to improve your marks, okay? When we are discussing this paper, this writing paper. So some of you might think that, so those who are watching this session or those who are attending for that classes, so if someone watching this recording, please remember, I will prove you that online paper class is also possible. I told you paper writing and everything is possible, right? So paper writing is very, very important. It doesn't matter whatever happen, I will give you limited time period to write down the paper, right? So all I expect from you is your honesty, not even your marks. I don't worry about your marks, right? So I want you to practice how to write a paper within limited time period. You will understand when you go for the examination, right? Because time management will be very important thing when you go for the examination. For the MCQ paper, you can manage anyhow because chemistry MCQ paper is really easy. So the issue is with the essay paper, right? Not next week. Following week, we are going to write down the essay paper. For the essay paper also, I'll give you 2 hours, 4 questions, 2 structured essay and 2 essay questions. Within 2 hours, we are going to do that one. Okay. So take this experience, right? Practice lot of questions, do the papers, and let's improve your marks. Okay. So we can do this one. Within online also, we can do this one, right? And you have to do the past papers also. Past papers also very important. So do the past paper book, right? Take some papers and by keeping timing, do the past papers, right? Take the stopwatch, right? Keep that one near with you, right? Go for your room or your working place. Tell your family members, don't disturb me. I'm going to write down a paper. So therefore, don't disturb me. So you have to what? Make that environment by yourself, right? So first of all, we have to practice our mentality should practice the exam mentality, right? We should go for the exam mentality. So that's what we are expecting from paper writing. Okay. So therefore, do that one honestly. Then you can practice the time management also, right? And the paper discussion will be conducted typically the same way. Let's discuss all the questions and everything, right? Okay. Now let's start the paper. So 24 OPC 1, MCQ 1 discussion. And before next class, I will give you a marks, and let's see who got the highest marks. Okay. Question number 1. Which of the following does not indicate in the correct ascending order of electronegativity of oxygen, electronegativity of carbon, sulfur, and again carbon, and electronegativity of elements carbon, chlorine, and oxygen, right? So they're asking about which of the following does not indicate in the correct ascending order of the electronegativity, right? So let's quickly recall the theory. So when we talk about the electronegativity, right? When we talk about the electronegativity, what are the 4 factors affecting the electronegativity? First one is hybridization, and the second factor is formal charge, right? So the second factor is formal charge, and the third factor is oxidation number, and the fourth factor is surrounding atoms, right? Surrounding atoms. So these are the 4 factors affecting to the electronegativity. Remember, students, I told you that when the S character increases, for example, if you consider sp3 hybridization, sp hybridization, sp2 and sp hybridization, when the S character increases, electronegativity increases, right? When S character increases, electronegativity increases, right? Electronegativity increases, right? So what about the formal charge? When the formal charge increases, electronegativity increases. Electronegativity increases. You have to remember them, okay? We have learned these things in our theories. Increasing. So what about the oxidation number? For the oxidation number also same thing. When the oxidation number is increasing, electronegativity is increasing. What about the surrounding atoms? For example, if I consider in this way, carbon tetrafluoride and carbon tetrachloride, right? So you can see that if you consider the central carbon atom, hybridization is also equal. Formal charge is also equal 0. When you consider the oxidation number, that is also equal. Oxidation number is plus 4. So therefore, we cannot consider these three factors in order to compare the electronegativity of the central carbon atom. Therefore, we have to go for the surrounding atoms. So when you consider the surrounding atoms, we know that fluorine's electronegativity is greater than the chlorine's electronegativity. So therefore, fluorine is pulling electrons from carbon more than in chlorine. So therefore, what will happen? The positivity of the carbon atom is increasing. Remember, when the positivity of the carbon atom is increasing, that atom is high electronegative atom. We can consider that high electronegativity because we know the definition for the electronegativity. What does mean by the electronegativity? Electronegativity means ability to pull the bonding electron pairs by an element. So therefore, if it is positive, we can easily pull the electrons. So therefore, tell me which carbon atom is more electronegative? Which carbon atom? Carbon atom is connected to the fluorine atom or chlorine atom? Which one is the most electronegative carbon atom? For sure, definitely this one is the most electronegative carbon atom, right? Because I told you, come again, may recall this one, revise this one. If electronegative atoms are more electronegative atoms are connected to the central carbon atom, they are pulling electrons from the carbon atom. So this is actually more positive than this one. Because when you compare the electronegativity of fluorine and chlorine, fluorine is 3.5, fluorine is 4.0. Can you remember? So therefore, fluorine is pulling electrons more than in chlorine. So therefore, positivity of the carbon atom is increasing. Therefore, electronegativity is increasing. Okay. Yes. Okay. So these are the four factors affecting to the electronegativity. If you can remember this theory, that's very easy to answer for this question, right? Hybridization, formal charge, oxidation number, surrounding atoms. What are the four factors affecting the electronegativity? Hybridization, formal charge, oxidation number, surrounding atoms. When this character increases, electronegativity increases. When the formal charge increases, electronegativity increases. Oxidation number increases, electronegativity increases. And when the electronegativity of the surrounding atoms increases, so electronegativity of the central atom is decreasing. Remember that one, okay? Right. Now let's go for the question. So that is the theory you have to remember, okay? Very easy. See how easy these things are. Let's go for the question. It will take some time, doesn't matter, right? It will take some time to take answers, doesn't matter. Anyhow, try to go for the correct answers, okay? Right. Electronegativity of oxygen, they have given water molecule OH minus and H3O plus. Let's see which oxygen atom has the highest electronegativity. We know that if you draw the Lewis structures of these compounds quickly, so you have to quickly do them, okay? Because you know that how to draw the Lewis structures are, those things are very simple, basic stuffs, right? When you consider the hybridization of the oxygen atom, this is sp3. So therefore sp3, sp3. Therefore hybridization won't dominate here. What about if you consider the formal charge, right? In water molecule, oxygen's formal charge. What is the formal charge of oxygen? That is 0. And what about the oxygen formal charge here? -1. And here, what? What is the formal charge of the oxygen? +1. Now using the oxygen formal charge, can't you compare the electronegativity? Can't you compare the electronegativity? What should be the correct order of the electronegativity then? The correct order of the electronegativity should be, look at this one, H3O plus. This oxygen atom should have the highest electronegativity. And then H2O and then OH minus. I told you that when the formal charge is increasing, electronegativity increasing. Highest formal charge belongs to the H3O plus oxygen, and then water molecules oxygen, and the least one belongs to the OH minus. So therefore, this should be the correct order. But look at the answer they have given. They have given water, that means which means the least one, least electronegative oxygen atom. That is wrong. Therefore, I think the answer should be first one, because they are asking about the incorrect one. Which of the following does not indicate the correct ascending order? So this is not the ascending order they have given. They have given the incorrect order. So therefore, we can consider that is the answer for this question. But anyhow, let's check the others also. Okay, we have to check others also. Right. Let's go for the second answer. The second answer they have given here. Second answer they have given here is methane, CH4, and C2H4 and C2H2, right? If you have any doubts, put your doubts in the chat box. Don't speak to the mic. Put your doubts in the chat box. When I have time, definitely I will explain your doubts, okay? Right, okay. Now methane, we have ethene and ethyl. These are some organic compounds. Remember, these are the Lewis structures of these structures, given molecular formulas. And C2H2 is ethyl. We know, students, remember, this is the central carbon atom. What is the hybridization? sp3. What about this carbon atom? This is sp2. And what about this carbon atom? This is sp3, sp2, sp. I told you that when this character increases, what will happen to the electronegativity? Definitely, electronegativity is increasing. So therefore, the correct order of the electronegativity should be methane, CH4, C2H4, and C2H2. Right? So how we can consider this carbon atom as the central atom? Yeah, we have two carbon atoms. Both of them are similar, right? Both of them are symmetrical. So therefore, we can consider that electronegativity is, right? Yeah. So speed is bit higher. Could you please make the speed little bit? Remember, we are not discussing theories, huh? Okay, understood. This is a paper class. This is the typical speed. Right, okay. So this is the first paper of you. I'll reduce the speed. Okay. You have to edit for the speed, right? In the paper class, we can't do the classes like theory classes. Understood? Okay, right. Anyhow. Okay. Can you understand this one? Is it okay? Are we clear? Are we clear about this one? How did I compare the electronegativity of these carbon atoms? Any doubts? Anything else? Don't talk. No, I have exam tomorrow, so I have to care as much as possible. Okay, right. So tell me something. Should I go speed or slow? Huh? Okay, I'll go with the moderate speed, right? Okay. Right, okay. If you have any doubts, put your doubts in the chat box. Okay, right. Now let's go for the third one. Hey, if you have tomorrow examination, what are you doing here? I really appreciate that you are attending for the session. But if you have exam, prepare for the exam, right? Is this the way you are preparing for the examination? If it is suit for you, doesn't matter. Okay, good. Right, third one. What about the third one? Third one is hydrogen sulfide. Hydrogen sulfide, sulfur dioxide, SO2. And the next one is SO3. Right. Now let's consider the electronegativity. So what are the four factors I told you? Hybridization, formal charge, oxidation number, and the surrounding elements. First of all, let me draw the Lewis structures of these molecules. I know that drawing Lewis structures are nothing for you, right? Because these things are very easy. You have learned them in your theory classes, right? Sulfur trioxides look like this. Right. So what you can say about the hybridization? All of them have the same hybridization. sp2. Oh, sorry. This is actually sp3. And this is sp2. And this is sp2. So therefore, definitely we can consider that. I told you that when this character increases, electronegativity is increasing. So we know that in hydrogen sulfide, the hybridization is sp3. Therefore, the least electronegative sulfur atom belongs to the hydrogen sulfide. So therefore, we can write down hydrogen sulfide here. And now we have to compare only sulfur dioxide and sulfur trioxide. When you consider the formal charge, what about the formal charge? Formal charge of all the sulfur atoms are equal. That is 0. If you consider the oxidation number of this sulfur atom is -2. Oxidation number of this sulfur atom is +4. Oxidation number of this sulfur atom is +6. -2, +4, and +6. I told you that when the oxidation number increases, what will happen to the electronegativity? Electronegativity is also increasing. When the oxidation number increasing, electronegativity also increasing. Now tell me, among sulfur dioxide and sulfur trioxide, which one should have the highest electronegative sulfur atom? Definitely sulfur trioxide. Therefore, The second highest one is sulfur dioxide, and the highest one belongs to the sulfur trioxide. The variation they have given is correct. Yes, they have correct. Very easy, right? These things are very easy. Completely theory. Number 4. The fourth one they have given here is COCl2, HCN, and carbon dioxide. So let's quickly draw the Lewis structures for them also. Right? Carbon is the central atom surrounded with 1 oxygen atom and 2 chlorine atoms. This is the Lewis structure. And if you consider HCN, this is the Lewis structure. Carbon dioxide is look like this. So these are the Lewis structures. Right? So what you can say about the hybridization? This is sp2, and this is sp, and this is also sp. Right? So therefore we can tell that for sure COCl2 should have the least electronegativity. Why? I told you that when S character increases, electronegativity is increasing. So therefore the least electronegativity belongs to the COCl2. COCl2. Now let's compare HCN and carbon dioxide. When you compare HCN and carbon dioxide, so since the hybridization is same, I will go for the next factor. Next factor is formal charge. What about the formal charge of the central carbon atoms? That is 0. Both formal charge is 0. If you go for the oxidation number, very easy. Look at this one. Nitrogen -1 + 1, -1 + 1, -1 + 1. Carbon is +1, right? Now, if you consider carbon hydrogen bond, hydrogen is +1, carbon is -1. +1 -1 will cancel off. Oxidation number of this carbon atom will be +2. If you consider this carbon atom, we know that it is surrounded by oxygen atoms within 4 bonds. Definitely oxidation number should be +4, +4. Then tell me who has the highest oxidation number? This carbon atom. So therefore we can consider that HCN is the second highest electronegative carbon atom, and carbon dioxide is the highest electronegative carbon atom. Right? Very easy. This is really easy. Nothing, huh? Right. Now let's go for the fifth one. If you go for the fifth one is, this is not all about writing everything on the whiteboard. Huh? I told you this is not the theory class. Try to understand everything. I'm revising all the theories you have learned. If you can remember the theories, you can get the answers. Okay. Don't try to write down the answers. If you have time, write down. If you don't have time, leave it. Just listen. That is enough. Okay. They have given the elements carbon, chlorine, and oxygen. Students, we learned the Pauling's electronegativity table in the first unit. According to that table, can you remember the values for the electronegativity? Carbon's electronegativity is around 2.5 again. Chlorine is 3.0. Oxygen is 3.5 again. So therefore, tell me who has the highest electronegativity? Oxygen. So the next one is chlorine, and the least one should be carbon. Right. Now tell me, what is the answer? What is the answer for this question? They're asking which of the following does not indicate in the correct ascending order of the electronegativity. First one, as I mentioned you, this is not the correct order they have given. The order they have given, they have exchanged the water molecule and OH minus. So therefore, that should be the correct answer, right? So please raise your hand who got the correct answer for the first question. Anyone here? Please raise your hand. Anyone here got the answer, correct answer for the first question? Hidurshan, good. Zara, very good. Right, okay. Okay, right. If you have any doubts, let me know, right? Right. Shall we go for the second one? Let's go for the second question. In the second question, they have asked in which of the following hybridization of the central atom are not the same, right? They're asking about the hybridization. Let's quickly draw the structures, right? Let's quickly draw the structures. Second one, right? So let's go for the second question. In the second question, they're asking about in which of the following hybridization of the central atom are not the same. Let's consider ammonia and NCl3. Normally, without drawing the Lewis structures, you should be able to get the answers. But anyway, let's draw the Lewis structures anyway, because we can learn the Lewis structures here. So these are the lone pairs. If you consider the second answer is C2H. Students, that should be corrected as C2H6, okay? C2Cl2. So this is actually ethane. Sorry. Yeah, ethane. And this is C2Cl2. This is kind of a structure like this. Okay. Now, if you go for the third one is water molecule and hydrogen sulfide. Very easy. Everything we have learned, right? These structures are very easy. Water and hydrogen sulfide. Oxygen is the central atom. Sulfur is the central atom in this molecule. Oxygen and sulfur both are in the same group. Right? We know that. And the fourth one is methane and CHCl3. Methane molecule is look like this. And CHCl3 also same thing. Chlorine atoms came instead of hydrogens. Right? Now let's go for the fifth one. Fifth one is beryllium dichloride, BCl2, and the second one is C2H2. Beryllium dichloride is linear molecule. This is ethyl or acetylene. In organic chemistry, we are going to learn about this one, okay? Right. So these are the Lewis structures. Now let's check the hybridizations. In which of the following hybridization of the central atom are not the same? Here there should be lone pair. What is the hybridization of ammonia molecule? Central atom, sp3. Ne? How did you derive the hybridization? Can you remember? When you count the VSEPR pairs, we can derive the hybridization. Remember, students, VSEPR pairs means sigma plus lone pairs. Right? If the VSEPR pairs are 2, we consider hybridization is sp. If the VSEPR pairs are 3, we consider hybridization is sp2. If the VSEPR pairs are 4, we consider that is sp3. If it is 5, sp3d. If it is 6, we consider that is sp3d2. Neither. You can remember. Right. And now look at this one again. What is the hybridization of this molecule? sp3. Eh? And this one, we can consider both the carbon atoms are same. Both the carbon atoms are central atom. I'll take one, sp3. Eh? What about this one? This is sp hybridization. Then this one should be the answer. Eh? They are asking about the molecules which have the different hybridizations. I think second one should be the answer. But anyway, let's go for the others also. We don't know. Sometimes we can have two or three answers. sp3, sp3. Ne? What about this one? Methane. Methane also sp3. And here also this is sp3. If you consider beryllium dichloride, sp. Ne? Acetylene, sp. Ne? Right. So in the first answer, first couple is okay. Third couple is okay. Fourth couple is okay. And the fifth couple is also okay. So the issue is with the second couple. Right? So in this molecule, all the carbon atoms are sp3 hybridized, and here carbon atoms are sp hybridized. So their hybridization is completely different. Answer should be second. Question number 2, answer is second one. Raise your hand who got the correct answer for the second question. Good. Right. Okay, very good. Okay, right. Now let's go for the third one. Third one. Right. Third one, they have given that how many number of moles of Ki in needed to react with FeMnO3 in acidic medium. Potassium iodide is going to react with FeMnO4 twice in acidic medium. Right. So let's write down the redox reaction quickly. Right. Remember, students, we have learned that under the standard reduction half reactions and the standard oxidation half reactions, I minus is going to definitely convert into I2. Neither. And if you consider FeMnO4 thrice, since this is in the acidic medium, I will put the H plus in the left hand side. Look at the way I'm going to balance the reaction. Okay. If you don't know how to balance the reaction, okay, now today you can learn. We know the standard half reactions, I minus is going to convert into I2. We know that FeMnO4 thrice. This is ferric permanganate. Ferric permanganate is made by Fe3 plus cation and MnO4 minus anion. We know that in the acidic medium, whatever the medium, Fe3 plus is going to convert into Fe2 plus, reducing. MnO4 minus is going to convert into Mn2 plus in the acidic medium. Right. Now you can see that. Who is going to oxidize here? I minus is going to oxidize into I2. Remember, students, there are two iodine atoms here. Here we have only one iodine atom. Therefore, let me put here 2. So therefore, summation of oxidation numbers will be minus 2. Here 0. So minus 2 to 0, it has removed 2 electrons. Therefore, I will put here 2. Can you understand? Here there were 2 atoms, iodine atoms. Therefore, I will put here 2. First of all, I'll balance the number of atoms and then take the summation of oxidation numbers of those 2 atoms. And here oxidation number is 0. So therefore, the total increment is 2. That means 2 electrons are removed. If we consider ferric permanganate, here we can see that oxidation number of iron here, that is plus 3. Plus 3T, plus 3,2, plus 2, it's reducing. How many manganese atoms are there? There are 3 manganese atoms. Therefore, let me put here 3. If you consider the oxidation number of manganese in the permanganate, X minus 2 into 4 is equal to minus 1. So therefore, X equal plus 1. That means manganese oxidation number is plus 7. How many atoms are there? 3 atoms. Therefore, plus 7 into 3 is plus 21. Right. Now, manganese, here oxidation number is plus 2. Since there are 3 atoms, let's consider that is plus 6. So, ladies and gentlemen, look at this one. Fe2 plus is going to reduce into Fe2 plus. Fe3 plus is going to reduce into Fe2 plus. Permanganate is going to reduce into Mn2 plus. So, in the same compound, cation and anion, both of them are reducing. So, therefore, we have to consider the total reduction, total number of electrons that are gained. Plus 3 and plus 21, that is plus 24. Plus 24. Here, plus 2, plus 6, that is plus 8. Right? Plus 21 to plus 8. What is the difference? The difference is 16 electrons. Neither. Difference is 16 electrons. If you consider the total compound, why I consider the total compound? Both the cation and anion are what? Reducing. So therefore, 16 electrons. 16 electrons are gained. Now, in order to balance the reaction, I told you that, right? In the theories, I told you that balancing redox reaction means we are equalizing the total increment with the total decrement. In order to equalize it, let me put here 8. Then only it will be equalized because there are 16 electrons there. Therefore, I will multiply this one by 8. Here 8 and here. Now look at this one. Already we have 2. When you multiply this one by 2, we have to convert this one into 16. 16. Right? How many oxygens are there? There are 12 oxygens. I will put here water molecules to balance the hydrogens and oxygens. Since there are 12 oxygens, let me put here 12. Now, how many hydrogens are there? 24. Therefore, let me put here 24. Look at the reaction. All of the elements and charges also balancing. If you consider the charge of the left-hand side, is plus 24 minus 16, that is plus 8. If you consider the charge in here, right-hand side, plus 2 plus 6 plus 8. Charge is also balancing. So equation is completely balancing. So they're asking how many number of moles of potassium iodide is needed to react with FeMnO4 thrice in the acidic medium. How many? 16. Very easy. If you know how to balance a redox reactions, these things are nothing for you. Tell me anything this is you are finding difficulty. If you are finding anything difficult here, that is because of you only. You have learned all the theories, you haven't practiced the questions. So the fault is with you, okay? So therefore practice lot of questions, then you should be able to get the answers right? Please raise your hand who got the correct answer for this one. Please raise your hand. Najima. Najima, okay, very good. Very good. පියුමි අද මුදිත සර්ගේ ක්ලාස් නෑනේ. මං සදුනි මිස්ගෙන් අහලා තමයි මම අද ක්ලාස් එක දැම්මේ. මේ ක්ලාස් එක මම දාලා තියෙන්නේ මුදිත සර්ගේ ක්ලාස් තියෙනවද නැද්ද කියලා. ඒ කියන්නේ ටීචින් ෆස්ට් එකේ කාගේවත් ක්ලාසස් එක මේක ක්ලාස් වෙන්නේ නෑ. 24 බැච් එකේ ක්ලාස් එකක් නෑ. මොකක්ද හරියටම ක්ලාස් එක මට කියන්න? එක්ස්ට්‍රා ක්ලාස් එකක්. හරි ඒක අද විතරයිනේ. ෂේප් නේ. ඊළඟ සතියේ ඉඳලා ඒක මැනේජ් කරගන්න පුළුවන්. ඊළඟ සතියේ එහෙම එකක් නැහැ නේ තියනවද ආපහු? හරි. හරි හරි අවුලක් නැහැ ඒක ප්‍රශ්නයක් නැහැ හරි. ඒක අවුලක් නැහැ. අද පේපර් කරගන්න බැරිච්ච අවුලක් නැහැ. හැබැයි ගෙදරදී මේවා try කරන්න ආපහු හරි. Next question. Question number 4. Question number 4 is related to the quantum numbers. Please, if you have any doubts, please put your doubts in the chat box. Okay, I'll explain you. Okay, doesn't matter. I'll explain you if you have any doubts. Question number 4. The number of Zara, Hafsa, Amani, everything is okay? Do you have any doubts? Madhuri? Okay. Good. Right. Okay, good. How the pay? Sheshan? Okay, everything? Idurushan? Okay, right. So can I know the answer for the second one? Second one answer is second one. Question number 2 answer is 2. Right, okay. Now let's go for the question number 4. Students, question number 4 is really easy. Question number 4 is really easy. That is related to the quantum numbers. I believe that most of you got the correct answer for this one. This is related to the quantum numbers. Right, quickly. What are the 4 types of quantum numbers? Quickly. What are the 4 types? N, L, ML, MS. Right? So tell me what does mean by each quantum number? N means principal quantum number. L means azimuthal quantum number. ML means magnetic quantum number. And this is spin quantum number. So this is representing the principal energy level. Principal energy level. Right? We know about these things. Very easy. So the second one is representing the sub energy level. Sub energy level. And magnetic quantum number is representing what? That is about the orbital type. And magnetic spin quantum number is representing the spin or direction. That means in an orbital, which electron is that? Okay. So these are the 4 types of quantum numbers. Very easy. Now let's go for the question. They have given the number of atomic orbitals. Are they asking about the number of atomic orbitals that can exist as quantum number n equal 3, n equal 3, and ml equal 0. Right. So what does mean by n equal 3? N means the principal quantum number. That is for third principal energy level. ML means magnetic quantum number. That means the which orbital is that. Right. First of all, let's go for the third principal energy level. if you go for the third principal energy level, first of all, tell me students, what are the sub energy levels we have? We have S sub energy level, neither. And then we have P sub energy level. And then we have D sub energy level. Because number of sub energy levels are equal to the principal energy level number. If you assign the L value for S is L equals 0. For this one, L value is L equal 1. And this is L equal 2. But they haven't given L value. So therefore, the answer is regardless the L value. So actually, answer is depending on the N equal 3 and ML equals 0. That means principal quantum number and the magnetic quantum number. In order to go for the magnetic quantum numbers, we have to consider how many orbitals are there. In S sub energy level, 1 orbital. P sub energy level, there are 3. In the D sub energy level, there are 5 d orbitals. So what are the magnetic quantum numbers that we are assigning? For the S, we are assigning 0. If there are 3 orbitals in the P sub energy level, we assign -1, 0, +1. For the D sub energy level, -2, -1, 0, +1, +2. And now tell me, how many orbitals are there which are having ML, magnetic quantum number 0? May 1, 2, 3, 2, 9. Only there are 3 orbitals. Easy, neighbor. See how easy these things are? Question number 4, answer is 3. Definitely in the examination, they will give you the quantum number question. Huh? Please raise your hand who got the answer. Correct answer, quickly. Everyone should get the answer, okay? These things are very easy. Response is not good, huh? Okay, let's see, will you? Since this is the first paper, doesn't matter. Right. Question number 5. Effective nuclear charge, ZeFF, felt by the valence electrons in bromine atom. Since the periodic table is given, you know the atomic number. So what is the atomic number of bromine? Atomic number of bromine is 35. So using that one, you can calculate the effective nuclear charge of this one. That is very easy. So let's do the calculation quickly. Right. Okay, right. I'll erase this one. Question number 5. ZFF. Effective nuclear charge is equal to, recall the things that we learn, effective nuclear charge. The things that you have learned in your first unit. Remember, effective nuclear charge is equal to Z minus S. So what does mean by Z? Z means nuclear charge, right? And S means shielding effect. So this is nothing else, the shielding effect. So normally, shielding effect is measured by calculating the number of co-electrons. Number of co-electrons means number of inertial electrons. Nuclear charge is measured by number of protons, neither number of protons. Why we are using effective nuclear charge? We can use effective nuclear charge in order to measure the radius, in order to compare the radius. Effective nuclear charge is inversely proportional to the radius. Remember, students, when the effective nuclear charge increases, what will happen to the radius? Radius is decreasing, right? So actually, effective nuclear charge is the combination of the nuclear charge and the shielding effect. We know about the nuclear charge. Nuclear charge means number of protons. When the number of protons are increasing, what will happen to the radius? Radius is reducing. What about the shielding effect? Shielding effect means nothing else the number of co-electrons, inertial electrons. When the shielding effect is very high, radius is high. Okay. If you want to write down this equation, quickly write down. Okay. And when the effective nuclear charge increases, radius will decrease. Okay. So that's the theory part. If you go for the question, they're asking the effective nuclear charge fell by the valence electrons in bromine atom. First of all, bromine atomic number. Since I have given you the periodic table, you should be able to write down the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p5. So this is the electron configuration for the bromine. 10, 30, 35. So what are the inertial electrons? That means co-electrons. So outermost energy level is fourth principal energy level. So therefore we can consider these are actually considered as the co-electrons, right? So these are co-electrons and these are valence shell electrons. valence shell electrons, right? So therefore, ZFF for the bromine atom, for bromine, this is equal to, what is the nuclear charge? Nuclear charge is 35. Number of protons are 35. Number of co-electrons, that means shielding effect. So if you calculate the shielding effect, that will be 10, 20, 28. 35 minus 28, what is the answer? 7. Effective nuclear charge felt by the valence shell of an bromine atom, of the bromine atom, is plus 7. That is really easy. Really easy. If you can remember the equation, these things are nothing for you. Look at this one. Right. Let's move for the next question. Question number 6. Question number 5 answer is fourth one. Nah? Question number 5 answer is fourth one. Raise your hand who got the correct answer for question number 5. Please raise your hand. Good. Okay, right. Let's go for the question number 6. Consider the following structure. What is the structure they have given? CH3, C double bond O, H. This is A and this is B, right? Right. They have given which of the following statement is correct regarding bond formation in the structure. Number 1, sigma bond of carbon-carbon is formed linear overlap of sp3 hybrid orbital of carbon A and sp2 hybrid orbital of carbon B. First of all, let's consider the hybridization of these two carbon atoms. Remember, students, carbon B atom is sp3 hybridized. I taught you how to derive the hybridization, and this is sp2 hybridized. Either A carbon atom is sp2 hybridized, B carbon atom is sp3 hybridized. Right. Now, when we discussing about the overlapping, right? So this is second unit theories, overlapping. Overlapping is two types, right? Two types, linear overlapping and the lateral overlapping, right? Linear overlapping means the bonding electron pairs lies on the internuclear axis. So these are the bonding electron pairs. Normally, from the linear overlapping only, sigma bonds are formed. Sigma bonds are strong. Neither. And lateral overlapping means the orbitals are overlapping laterally. That means this is the internuclear axis. The bonding electron pairs actually lie apart from the internuclear axis. So normally pi bonds are formed by this lateral overlapping. This is weak. And one more thing, from the pi bonds are only formed between p orbitals. P orbitals. Only involving there is p orbitals. Now let's go for the answers. So this is the theory you should know. That's all. These are some simple theories you learn. Sigma bond of carbon-carbon is formed by linear overlapping of sp3 hybrid orbital of carbon A. Wrong. Because carbon A atom, this is sp3 hybridized. Is this sp3 hybridized? They have given this is sp3 hybridized. Wrong. This is sp2. So therefore we can reject the statement. Second one, sigma bond of carbon hydrogen is formed by lateral overlap. No way, right? Normally sigma bonds are formed by always what? Linear overlapping. So carbon hydrogen, all the bonds are formed by linear overlapping. If it is a sigma, definitely if it is a single bond, that should be sigma bond. If there are multiple bonds, one is sigma and the remaining bonds are pi bonds. What about the second statement? Sigma bond, second statement is wrong. Pi bond of carbon hydrogen is formed. No way. Carbon hydrogen is containing only one bond, that is sigma, not pi. Wrong. Fourth one. Sigma bond of carbon-carbon is formed by linear overlap of sp. Oh, no. We derive sp2 and sp3. How it come sp? That is wrong. Then the answer should be fifth one. But anyhow, let's go for that question. Sigma, answer. Sigma bond of carbon-carbon is formed by linear overlap of sp3 hybrid orbital of carbon B. Yes, sp3. Linear overlap, sigma bond. And carbon A, sp2 hybrid orbital. Yeah, that's correct. sp2 carbon A, linear overlap. Correct. So therefore, question number 6, answer is fifth one. See how easy these things are, right? These things are not difficult. Right. Question number 7. Question number 7 is related to the oxidation number. That is really easy. Really easy. Thiosulfate is 2O3 2 minus. Thiosulfate, an ion. What should be the Lewis structure? This is the Lewis structure. Right. Look at this one. Let's calculate the oxidation number using the bonding method. Sulfur, there is no electronegative difference. Therefore, we don't assign the oxidation number through along this bond. If you consider this oxygen sulfur, -1 + 1 for oxygen, -1 + 1 for this oxygen, and here -1 + 1, -1 + 1. So therefore, we can consider that oxidation number is, what is that? +4. Oxidation number is +4. What is the valency? What is the valency of the sulfur atom? Valency is 6. Valency means capacity of forming bonds. How many bonds it has formed? 1, 2, 3, 4, 5, 6. Right? So therefore, we can consider the valency. Valency is 6. Valency is 6. Oxidation number is +4. What is the answer? Answer is number 1. Question number 7. Answer is number 1. Raise your hand who got the correct answer for question number 7. Please raise your hand who got the answer for the question number 7. Only one. What about the others? Oxidation number is +2. How it become +2? Session. Oxidation number. Look at the way. Again, look at this one. Thiosulfate, this is the Lewis structure. If you go through all the bond, when we are assigning the oxidation number through the bonding methods, we can ignore the sulfur-sulfur double bond. Since there is no electronegativity difference, we don't have to assign +1 -1. Right? Yeah, we have another doubt. Yeah. Number of atoms to bonded to for valency. Yeah, we can consider in that way. Zara, you are correct. So, Seshan, look at this one. Sulfur-sulfur double bond is ignored. And if you consider this sulfur-oxygen double bond, oxygen is the electronegative atom. There are two bonds, -1 for oxygen, +1 for sulfur. -1 for oxygen, +1 for sulfur. If you consider this bond, -1 oxygen, +1 sulfur. -1 oxygen, +1 sulfur. Then around the sulfur atom, the total oxidation number is +4. Right? The valency means the bonding capacity. How many bonds it has formed? 1, 2, 3, 4, 5, 6. So, okay, right. Question number 8. Let's go for the question number 8. No, not the atoms. We have to consider number of bonds. Right? Number of bonds. Understood? Not the atoms. Okay? Right. Okay, right. Now let's go for the next question. Question number 8. They're asking about which of the following has sp2 hybridization in its central atom. These things are easy, right? Let's start from carbon dioxide. So this is the Lewis structure for carbon dioxide, right? This is carbon dioxide. Second one is FNO2. FNO2 is like this. Nitrogen is the central atom, is surrounded by 2 oxygen atoms and the 1 fluorine atom. Always fluorine is forming only 1 bond. And here oxygen can form double bond and the other one should form single bond because nitrogen can only form 4 bonds. Right? If you consider third one is water molecule. Nothing to say. That is really easy. Number 4, ammonia. Again, nothing to say. What is this? And the fifth one, nitrous oxide. That is also easy. Nitrous oxide is look like this. Nitrogen nitrogen triple bond is formed. Here positive sign. Here negative sign. Okay. Now let's derive the hybridization. What is the hybridization? sp. And here sp2 hybridization. Here we can consider this is sp3. And this is also sp3. And this is sp. So they're asking about which of the following has sp2 hybridization. So the answer is the second one. Question number 8. Answer is second one. Really easy. Some of the questions are difficult. Some of the questions are very easy than you think. So this is question number 8. Question number 9. What is the number of possible resonance structures for H2C2O4? Right. H2C2O4, that is oxalic acid. Huh? Question number 9. This is oxalic acid. H2C2O4, oxalic acid. Remember, when we are drawing the Lewis structures, this is the way. This is the skeleton, right? We can draw the resonance structures. We can draw a structure like this. And we can draw another structure like this. This is negative sign. And here, if you make double bond here, this is positive. And then we can make double bond here. This is single bond, negative sign. And this is double bond in this way. And then we can draw another structure like this. This is negative sign. Positive. Positive. Right? We can shift the double bonds only these 2 places, right? We don't have any other options. Yeah, so therefore answer is third one. We can draw only 4 structures. Answer is third one. We can draw 4 resonance structures in this way. So therefore this is the answer. We can draw 4 resonance structures. This is the way, oxalic acid, right? Double bond there, here double bond here, here double bond, upward down double bond, and here horizontally 2 double bonds. Question number 9, answer is third. Okay. Right. Please raise your hand who got the correct answer for question number 9. Okay. Question number 10. Let's go for the question number 10. Question number 10, they have given that correct increasing order of the decomposition temperature is given. Decomposition temperature is given, right? Let's see. Decomposition temperature. Remember, actually, this is related to the ionic and covalent nature. Ionic and covalent nature. So when you consider the ionic and covalent nature, so what should be the factors determining? Actually, we have to determine the polarizability and the polarizing power, right? So therefore, when you consider the ionic nature and covalent nature, we have to consider the cations polarizing power, and the anions polarizability. Okay, and if you consider the cations polarizing power, this is directly proportional to the charge and inversely proportional to the radius. That means when the charge increases, polarizing power increases. When the radius decreases, polarizing power decreases. If you consider anions polarizability, this is directly proportional to the charge as well as radius. When the radius increases, polarizability increases. When the charge increases, polarizability increases. So you have learned these things in the second unit. Neither. Right? So when what will happen when cations polarizing power and polarizability increases? What will happen to the covalent nature? When they are increasing, covalent nature is also increasing. Covalent nature is increasing. Covalent nature is increasing means ionic nature is decreasing. Right? When the cations polarizing power increasing, covalent nature is increasing. When the anions polarizability increasing, covalent nature is increasing. And here the factors affecting to the polarizing power of the cation and the polarizability of the anion. So what are the compounds they have given? Beryllium carbonate, magnesium carbonate, calcium and barium. Yeah, calcium and barium. Beryllium carbonate, and then magnesium carbonate, calcium carbonate, barium carbonate, not the strontium carbonate. They have given barium carbonate. Right. We can ignore the anions polarizability because anion is same. Carbonate is the anion. So therefore, we can ignore the carbonate anion. So therefore, the cations are beryllium 2 plus, Mg 2 plus, calcium 2 plus, and barium 2 plus. So these are the cations. So when you consider the covalent nature or the ionic nature, right? So what we have to discuss here? Cations polarizing power. I told you that the two factors affecting the polarizing power is charge and the radius. If you consider these cations, these elements are belong to the second group of the periodic table. Therefore, charge is same. What about the radius? Students, what about the radius? Radius is increasing down to the group. Neither. Radius increasing down to the group. We know that. Now tell me, when the radius increasing, what will happen to the covalent nature? When the radius increasing, covalent nature is reducing. Covalent nature is reducing. Covalent nature is reducing. Is reducing. Then what will happen to the ionic nature? Ionic nature increasing. Ionic nature is increasing. Now tell me what will happen to the decomposition temperature. Remember, when the ionic nature is very high, the ionic lattice is very strong than the covalent nature, covalent bonds. So therefore, we can consider that thermal decomposition temperature is very high. Thermal decomposition temperature is very high. Thermal decomposition temperature is very high. Temperature is high. For this direction, thermal decomposition is increasing. So therefore, what should be the correct answer? The correct answer should be beryllium carbonate should have the least thermal decomposition. Then the magnesium carbonate, calcium carbonate, highest thermal decomposition temperatures belong to the barium carbonate. So this should be the answer. Answer is third one. Question number 10, answer is third one. Very easy. Look at this one. Raise your hand who got the correct answer for this. Good. Question number 8, the answer is give me FNO2, second one. Question number 8, answer is second one. Right? If you have any doubts, put your doubts in the chat box. Right. Question number 11. Which of the following pair of molecules has the same electronic geometry? Electronic geometry. Again, the Lewis structures. Right? Let's see. This is really easy. Question number 11. Look at this one. Number 1. Water and sulfur dioxide. Number 2. NH3 and IF5. Number 3, ICl3 and ICl2 minus. Number 4, CCl4 and PCl6 minus. Yo, these things are very easy, right? We have discussed these things. Carbon tetrachloride and PCl6 minus. PCl6 minus means here phosphorus is forming 6. That's all. And phosphorus has negative charge. Right? Number 5, ICl3 and CCl4. ICl3 is that. So CCl4 means this. Okay. Now tell me electron pair geometry. So which one has the same electron pair geometry? So this is tetrahedron. And this one, trigonal planar. I'm talking about the electron pair geometry, okay? Trigonal planar. What about this one? Tetrahedron. What about this one? 6. Octahedron. If not, we can tell a square bipyramidal. And this is trigonal bipyramidal. Trigonal bipyramidal. And what about this one? This is also same, trigonal bipyramidal. Electron pair geometry, right? If there are 5, definitely electron pair geometry, trigonal bipyramidal. What about this one? Tetrahedron. And this one, octahedron. So this one is, I told you that this is a trigonal bipyramidal. And this one, tetrahedron. So then tell me which pair has the same electron pair geometry? Number 3, ICl3 and ICl2 minus. Answer is third one. Answer is third one. Next question. The increasing order of dipole moment of AlCl3, NCl3, and PCl3. AlCl3, NCl3, and PCl3. Let's see. The increasing order of dipole moment of AlCl3, NCl3, and PCl3. Now look at this one. Question number 12. So the structures are AlCl3. Let's consider AlCl3 look like this. Actually, here we have to consider the resultant dipole moment. Okay. AlCl3 is actually a non-polar molecule. Neither. If it is non-polar molecule, what should be the resultant dipole moment? Resultant dipole moment should be 0, right? And then we have NCl3. and then we have PCl3. Right. Okay, now look at this one. For this molecule, resultant dipole moment is 0. If I consider this one mu1, that is 0. If you consider nitrogen and chlorine, who is the most electronegative atom? Remember, chlorine is the most electronegative atom. Even though in the Pauling scale they have given nitrogen and chlorine both are same, remember chlorine is the most electronegative atom, right? If you go for the second decimal point, chlorine has the highest one. And here we have small dipole moment because of the lone pair. But anyway, the resultant dipole moment is downward. That is mu2. Mu2 is not greater than, mu2 is not equal to 0. If you consider PCl3, so here phosphorus is like 2.1 electronegativity, chlorine is 3.0. So therefore, chlorine will pull the electrons from phosphorus atom more than nitrogen, more than in nitrogen. So therefore, resultant dipole moment is downward here. This is mu3. Mu3 is not equal to 0. So since the electronegativity is very high between chlorine and phosphorus, chlorine is pulling the electrons from phosphorus more than in nitrogen, right? In here also chlorine is pulling, but more than in nitrogen, phosphorus is pulling the electrons. So therefore, mu3 is greater than mu1, mu2. So mu1 is the least one because their resultant dipole moment is 0. So therefore, we can consider that increasing the order of dipole moment is this variation. So this variation is PCl3 and then NCl3, and the least one belong to LCl3. Dipole moment. Okay. So this answer is given in first one. Yeah, answer is first one. Raise your hand who got the correct answer for this. Please raise your hand. Please raise your hand. Got the answer, correct answer for this? No one. Oh my God. Right. Okay. Right. So now time is already up 7:45. Doesn't matter. Next week also we are going to discuss this paper. So next week, whatever the time, I'm going to finish the paper. So this is our paper class procedure. We are continuing this way. In the first week of the month, what we are going to do, we are going to do the MCQ paper. I'll give you 2 hours. And in the remaining 1 hour, we are going to discuss the paper. And in the following week also, in the 3 hours, let's take to discuss the paper, right? We are revising all the theories and discussing all the questions. And in the third week, we are going to write down the essay paper again, 2 hours, and the remaining hour discussion. And the fourth week of the month, we are completely discussing that remaining question in the essay paper, right? So therefore, this is the way of conducting my paper class. This is the same way that I'm conducting my paper class for the physical batch also, right? For the physical batch, I didn't start the paper class because 23 batch is still there. Until they go for the examination, I won't start the physical paper class. But anyway, I started the online paper class a bit earlier because we can do more papers. Until the examination, this paper class will be continued for my, especially for my theory students, but others also can join. Okay, right. So please tell me, today we discussed 12 questions. Do you have any doubts? The remaining 38 questions will be discussed in the next session. For that one, you have to join at 7:30 next week. Any doubts? Anything you want to ask? Please ask me. Okay. Yeah, definitely. Definitely. Hopefully, this will be helpful for you. So Mohammed do the examination very well. Okay. And if you can send me the paper also, you are DS neither, I can remember. My school neither. So send me the paper also, okay, if you can. Okay, good, right. Okay, I'll upload the recording to the WhatsApp group, okay? Don't worry. Okay, right. Okay, then I'm going to wind up the session. Let's meet on the next Monday, same time, 7:30. and let's finish the paper in that session. Okay, so until then, bye bye, have fun, good night. Okay, good night.